Okay, so this is your practical video for experiment X1, preparation and analysis of copper sulphate. So what we're just going to do here is we're going to get both videos playing again. So we'll play, and we will play. We will also, I would hope, mute. So we'll mute, and yes, there we go. We're open. So, different way of doing this with GoPro technology, with a fixed camera position as we see here, and at the side camera. So this is X1, and you've been asked to look at your materials: copper sulphate, ammonium sulphate, sodium thiosulphate, potassium iodide, thiocyanator, starch indicator, and these will be left out in trays here. And what you're going to do, so we're just going to move that over there, I think, for the moment, and get rid of that. You're asked here to look at your procedure, and you're provided with solution of copper sulphate, which is 1.5 to 1.25 molar, and 100 cm beaker. You're to weigh out 4.55 grams of ammonium sulphate. So this student here is now to use a 3 decimal point balance, we would hope. I think in here there is a weighing boat, and the student is going to take a spatula and we would hope measure out the quantity of 4.55 grams of ammonium sulphate, as you see here, add to 8 ml of water, and then to our 25 ml stock solution of the copper sulphate. Okay, which then, after a few minutes, crystallization should take place, as what we've got here. So we're going to look at this student and how they work. So we're going to see that we would hope that they're going to weigh out and spatula out the correct amount of ammonium sulphate. So they're doing that, and we're just going to move the camera along. We see that they're doing that. So there you go, 4.55 grams. And then the student then is to place this into 8 ml of water. So that's going over there. Student reading along. The full video files for anyone who wants to watch all of them will be on the university's Blackboard site under this section. So this student here is going to then get rid of that file. We're going to then see the student go to eye level. Perfect, these GoPro cams. Eye level for 8 ml of water, which satisfies this 8 ml of water, and then to this add it into the beaker. So we will hopefully see the student will move through this, taking the water, the beakers here. So the student's going to make the plunge and put the ammonium sulphate in, as we're going to see. There we go, be brave, get it in. There you go, perfect, in it goes. The water's going to go in, it's 8 ml. There we go, that's all very good. And then the student then needs 25 ml of the copper sulphate. So the student is going to place this onto the hot plate stirrer with the flea and get it spinning. Nice for the student to do that. Obviously make sure you don't heat the plate up. Here comes the gorgeous blue copper sulphates, as we see here. And now the student, as indicated here, needs to take, what do we need to take? 25 ml. So the student is probably going to take it into a beaker. You could of course use a measuring cylinder here to measure out the quantity, or you're going to take the 25 ml here, the stated up to the marked level of the beaker. The student is doing that. And then we're going to then add it towards the stirred solution here of the ammonium sulphate. The student will hurry the students along. There we go. So the student still doesn't want to do that. There we go. I think the student's about to do this now. There you go, being brave. Pulls it in. You see there's a different colour. The blue kind of went for a touch of a turquoise at the moment there. So while we're seeing the student do this, so to the solution we've added the 25 ml of the stock copper sulphate. Within a few moments, crystals of the double salt, the copper 2 ammonium sulphate, which would expect to be less soluble in either component single salts, should begin to form. So allow a few minutes for the crystallization process to take place. So you're going to allow that to happen. So the student's messing with the GoPro camera there. So probably now starting to scratch the crystals out, if that's not the case. So this student is going to start hopefully scratching the crystals out. And yes, using the stirring rod, and one of the demonstrators might come along. So scratch down one part of the glass to make sure that the crystals start to flock out. Hopefully this is going to be the case. It's gorgeous when you can just cheat with a GoPro cam and just hurry along. We're just hurrying along as we see. There you go. So the student's spending a few moments here to get the crystals to come out. And now they've decided to cheat, or to not after a few moments to get this into a dish of ice and to keep scratching down one part of the glassware to nucleate out the double salt. So hopefully we're going to see in a moment this student reach this utopia of getting the crystals to come out. I love this GoPro cam technology. We're just rushing through here. Student still beavering away, so this is a 20-minute clip here. The student's being very careful. Now see the University of Salford brand. Other universities, don't steal this off YouTube. This is Salford University's own learning material. So the student, that's a colour I would suggest, without being there on the day, well, was being there but not seeing this part of the practical, that is probably the precipitate of a turquoise kind of salt. So we're just going to pause for one. So the student's taken the beaker out of the ice. You can see there's a salt at the bottom. You see that green turquoise salt, and he's moving it around, and there's the salt at the bottom. So the student has indeed, after a few minutes, allowed the crystallization to take place. And now the student's going to filter the crystals using a butler funnel and wash them carefully with ethanol, and to repeat again. Okay, and after that they're going to wash twice with diethyl ether, and making sure that no flames are around. We don't want ether around with flames in the lab. And then they're going to dry the crystals between two filter papers and air dry for 20 minutes. At that point record the mass. So this student is very careful, got the crystals out, and then what we're hopefully going to see, I'm going to zip along here in the file. They're now selecting from the kit. So here, we'll just pause here. Here's the butler flask, the seal and the butler funnel, and this needs to be clamped into position, and here a piece of filter paper wetted down. So wetted down or placed down with ethanol. So obviously you all will wear laboratory spectacles at all points, but we don't want ethanol near the eyeball. So let's just see the student and the demonstrator making space on the bench. We like that as an idea. And I'm just going to pause here, because if I was to see you doing this in the lab and this has been filmed here, I would want this to be clamped. So I'm going to point this out here. This butler flask and funnel needs to be clamped onto the bench. So I would want this to be on a clamp stand and to be clamped in position so you don't knock that over. So I think this is going to move through. Yep, the student would be doing that. And I wouldn't be happy with that, and I would be coming over at this point saying all this glassware needs to be clamped. So we're going to see at the moment that there should be a cake of crystals in here, and what we want is that to be washed out with some of the 10 ml of ethanol. So you can scrape it out as the student is doing and transfer over. Note this gorgeous kind of azure, kind of bluey green, well, turquoisey green is it not? Kind of liquid, and the crystals here, I'm going to place them in there, so scrape them out and transfer with ethanol. But again, I would want this to be clamped as apparatus. So we just move through, and the student's taking the crystals out. Okay, that's fine. That's fine. So then the student's going to wash with ethanol and break apart the crystals with the end of the glass rod, and to wash with ethanol. So note they take the ethanol out with a dropping pipette, transfer around the side of the beaker, We don't want to contaminate the ethanol bottle by being slight, so we'll just move this along. Transfer the crystals out more into the butler flask. So we're going to move it through, scrape the crystals through. That's nice, really nice to see. Wash out again with that 10ml, breaking apart the cake of crystals with the ethanol. Let it dry and then repeat. So again, the student is just varying the vacuum on the tap when we're moving this through. So we're sucking it through here, and then the student is then going to get some ether, probably into dispensing it into this measuring cylinder, but again, well, this is ethanol, another 10ml. Students being careful with the ethanol. Okay, that's good. So sorry, there's the clamp and the stand. I would have want that to be used to secure the butler flask and the funnel. So here, probably that's the ethanol wash. Break apart, ethanol, let it dry, ethanol, let it dry. Same with the ether, 2 times 10ml, let it dry. So that's how we're going to leave it at that stage, and we'll pause there. The student's still washing with ethanol, and so we'll just move this forward because it's an ethanol wash twice, breaking apart as you see. And again, I want that clamped onto the bench. I'll be coming over to speak to you if I see you doing that. So this video's got through without my attention, but you know, errors are right if we keep them in, if we point out what the problem is. If you knock that over, all your crystals are over the bench. We don't want that. So the student's being very careful with the filtration unit at all points. We just move back here. The ether's coming out. The ether's coming out here. There's the ether bottle. Someone's on loan here. So yep, having a look what his friend's doing. Washing with ethanol and ether. Make sure you transfer the crystals off the rod as we see there. Just have a pause again. So around at this point here, the student's ready to dry the crystal, squeeze it between 2 papers and let it air dry for 20 minutes. So the student's got some crystals here. You can see the filter papers are here. Let's see in this clip what the student wishes to do. So he's probably washed with ethanol twice and ether, letting it air dry. So let it come through the vacuum for another, let's say 5-10 minutes after you put the last trace of ether through. You can use a spatula or your glass rod, so just keep breaking it apart so it looks a little bit drier, but have the full vacuum line on to really get it to dry, to suck the traces of solvent off. And then the student's ready to scrape out these crystals here, as we've seen here, with a glass rod or maybe a spatula, but I've used a glass rod. Take it onto the filter paper, scrape everything out as much as you can, get everything off, and then we're going to see, hopefully I'm rushing through this, you know, we don't want to live it moment for moment, we don't want a 3-hour video. We see then the student, a nice mass of crystals, look at that gorgeous colour of those crystals, and then the student should take the other piece of filter paper and pat down over the top to dry and squeeze, and obviously to get the last residual part of solvent off. And that would get us down here. Then you're going to be asked to record the yield. That's what the student's doing now. That's nice. Pack it over the top and break apart. Yeah, that's really nice. Like to see that. Break apart. Large surface area and pat down with the top part of the filter paper to take any residual moisture off. Notice one of the demonstrator here is rightfully so insisting to the students at all points clean up as you're going along. That's really important to say. I will make the verbal announcements, but clean up as you go along. Look at the bench here, it's nice and clean. That's lovely to see in an undergraduate laboratory. There's very little spillage over the surface of the bench. So now the students at this point, they're going to get ready to record the yield. We'll have another pause while I swap the video over. So this student now has dried the crystals for this 20 minutes of time. Now ready to record the yield. So again, very careful, got a weighing boat. You may as well wish to think about maybe getting a glass vial. So take a pre-weighed glass vial, take a glass vial and weigh it beforehand, and instead of using the weighing boat, scrape the crystals into a glass vial of the weighing boat. This student decides to use a weighing boat, so I'm going to record the mass of the weighing boat. So I'd have actually just paused there. I'm going to move the student slightly back. just go over here. I'm going to pause. So I'd have taken the balance and turned it to 0, put the weighing boat on, and recorded the mass in your lab book, in your sheet. So you would know then the weight of the weighing boat. You could turn again when the weighing boat is on, so I think this is what the student does here. They're going to take, messing around, put the boat on. But I'd have turned before and put the boat on to know the mass, but the student's going to turn, yes, and now we're going to then scrape the crystals in. The student's going to scrape the crystals in. So you could take the boat off towards nearer the paper, scrape the crystals in. But this student now has recorded a mass of the double salt, this ammonium copper sulphate. So I'm just going to pause there. So the student's got to that point. Now you have to weigh out accurately on analysis. So you've done the preparation now to analyse. Weigh out accurately 0.5 grams of your product, dissolve again in water, 25 ml of hydrochloric acid and about 0.2 grams, sorry, that's 2 grams of potassium iodide. Make sure all the iodide is dissolved, and then you're going to titrate against thiosulfate in a redox titration to look until an iodine colour fades to a pale yellow. At that point you're going to add some thiocyanate and starch indicator and titrate until it's colourless. Okay, so that's what you're going to do now. So we'll just see what the student does. Move back, I would hope. So the student has added the amount, therefore 0.5 grams accurately, of the turquoise salt into a beaker of water. So we've missed that out, but the student is adding here the 0.5 grams of your product, well known to be the mass, into the beaker with water. And then the student we're going to see is going to add about 2 grams of potassium iodide, which I suspect is that bottle. Let's have a look at that one. So the student is going to weigh out onto another clean weighing boat about 2 grams of potassium iodide. Put that into the beaker and mix well so everything dissolves. So we're going to see the student get the 2 grams of potassium iodide. Well done. Near enough. Messing. There we go. And the student is then going to add 2 grams of potassium iodide to the beaker, we would hope, with the double salt in the water, and we'll move that through. Done that perfectly. Look at that colour that we see there. So I need to mix it all together. It says here, make sure the potassium iodide is dissolved, and then you're going to titrate the colour. It's like a murky colour, that, with thiosulfate in the burette. There's the burette with thiosulfate, until the iodine colour fades to a pale yellow. Okay, so the student's decided to mix it all together to get it to dissolve. The student then is taking the burette, and the burette is going to be filled with the potassium, as we're seeing here, with the burette is being filled here with the sodium thiosulfate at 0.1 molarity, so the burette is being filled, and the student is trying to do that carefully. And then this colour, we're going to titrate it here now, so we're titrating it until a pale yellow is observed. So let's see what the student tries to do. He's taking the flea out. Right, Nicola's having a good look. You may see Nicola this one of the years. Hopefully Nicola guessed that student may be around for many years. So the student's now starting to titrate, and we're going to see what colour. There you go. That's the colour. That's the colour. So once the student's titrated that to that colour, let's just stop there. That's the pale yellow colour, as we see here. Transferring it now to an Erlenmeyer flask, and adding the salt, potassium thiocyanate and starch indicator. So into this flask here is added again potassium thiocyanate, a gram approximately, so weigh that out and add it in, and then titrate again with the sodium thiosulfate until a colourless solution is observed. So let's just see what we've got here. So everything's added, and the student is titrating away still, and we want a colourless solution. Oops. Go back, and the student is titrating away. Pause here. So we'll just see here, they get this file over here. So again, we want an endpoint of a clear colourless solution, so that's probably what we're looking for. And again, this is the starch indicators added in, and the student is just going to make sure, we would hope, that we've got a clear colourless solution which is discharged from that pale yellow. Note the students here is using a tile, so obviously visually spot the colour change here as well. So when you're titrating, use the tile. So the student has prepared and then analysed, and you should repeat until you have concordant results. So what we're trying to do with these videos is just to show you how to do the practical work. The treatment of this will be issued internally within the laboratory for Salford University students to participate in. So again, this ends X1 of the Foundation Year Chemical Principle module at the University of Salford. I will stop. Thank you.